Hello, and thank you all for joining us today for this educational Innovize webinar. My name is Caitlin Nyan, and I'm part of the marketing team here in the Portland office. In this webinar, we'll talk about the best ways to integrate data for day-to-day maintenance operations that can and should feed hydraulic modeling for better capacity management of the network. For those of you who may not be familiar with Innovize, we have a long history of providing high-performing, innovative software solutions. Our intention is to make sure that in your work you can design, model, review, and manage with confidence. This also means that we strive to provide excellent customer service and support, and that we offer continuing education opportunities like these for engineers and others in our industry. Innovize offers a library of software programs for the design, analysis, and management of water infrastructure, like InfoNet, which you will see today. Now, on with our presentation. I'd like to introduce our presenters. Today's presenters are Tony Andrews and David Topman. Tony recently joined Innovize as an asset management product manager. He comes with us from Bentley Systems UK, where he was most recently principal product manager of asset management. Before that, he held various sales, technical service, and product roles for Wallingford Software. He also had more than a decade of experience as a GIS analysis and hydrologist. Tony's experience makes him an asset to today's conversation. David is Innovize's new Director of Asset Management. He has 36 years of experience in the water industry and has applied GIS to business process optimization, project analytics, and infrastructure management for the last 30 years. David spent his last 7 years at Esri as the Director of Infrastructure, Industry Marketing Strategy, among other roles. Before that, he was a manager of asset management with Colorado Spring Utilities, one of the largest and owned forest service utilities in the U.S. In addition, he has more than a decade of consulting and utility experience. David is a wealth of knowledge when it comes to today's topic, data and asset management. Thank you again for joining us. David, take it away.
Okay, yeah, thank you, Caitlin. We'll go ahead and there we go with the agenda here. Wanted to kind of go over. You'll see that today's presentation really is set in the context of CMOM. So we're going to talk a little bit about CMOM and SSOs. A little feature I have called the Director's Cut, and I'll actually get to talk a little bit about lessons learned from someone who has been in a consent decree. And then we'll have Tony kind of show you how we do things here at Innovize with a solution called InfoNet, and then touch real quickly on some training opportunities, and then, of course, one of my favorite sections, the Q&A. And really to kind of to start the show here, wanted to launch a quick poll just to get a feel for the audience of who's out there. So what is your primary role in asset management? If you could answer this poll here. Are you in IT, GIS? Are you from engineering, operations support, the business side, or not involved at all with asset management? Looks like about 55% of you have voted. We've got a strong engineering side showing up. That's good. 14% other. If you could throw in the chat window, maybe those of you that are in the other category, what maybe some of those titles might be, just to kind of let us know who's who. So, okay, well, it looks like pretty much everyone's voted. We have a huge turnout of engineering operations support, which is pretty well to be expected. So again, thanks for answering that poll. It helps us understand who's out there. So when we look at CMOMs and SSOs, or capacity management and operations maintenance and sanitary sewer overflows, really SSOs came out first. About in the summer of '96, the EPA started talking about SSOs, and based on kind of the vintage of the graphics in the report there, when this is almost even pre-color, when you're using hatch patterns, the causes of sanitary sewer overflows really haven't changed that much over the years. As to be expected, SSOs caused by pipe breaks and pipe blockages, makes up most of the reasons. But of course, then, I&I, and those of you that have vitreous clay pipe out there definitely understand I&I. And it really, talk about this a little bit later about insufficient system capacity. It wasn't until I was in that consent decree that I started realizing, pipes having insufficient capacity was a cause for alarm in the asset management program as well. And then, of course, good old power failures. If you have a power failure at a lift station, that can be cause for concern with all that gravity feed coming into a pump station and nowhere to go. So they started talking about these things, I say, back in the summer of '96. And then, and the whole reason for that, again, more state-of-the-art graphics. Back in 1996, just trying to communicate what the issues were with sanitary sewer overflows really is about protecting, environment and health. And so, that was back in the summer of '96, over 20 years ago. And then really, though, about 10 years later, CMOM came out, the Capacity Management and Operations and Maintenance. And here they, started talking about a lot of the different details of trying to understand the characteristics of your system. They really wanted to make sure that you knew what was in your system, what was going on in your system, that you identified all the different assets, specialty assets such as, say, drop manholes from other manholes, but also then understanding, the asset performance, what was going on in the collection system with, understanding the flow velocities, such as peak flow and low flow conditions, and found that low flow conditions really, were troublesome with stoppages and such. So really they were trying to get you to kind of, think about the different aspects of your collection system and, have those all documented. So really, the sections here at Innovize that we focus on, CMOM sections 2.26 and 2.27, where they talk about the benefits of modeling and mapping. That's what you'll kind of see a little bit here, a little bit later on when Tony starts doing some of the demonstration there. One of the things about the CMOM best practices, they really kind of went into a whole list, basically a recipe for success, talking about designing and constructing for O&M, not just design and build, but, when you go to O&M, and that was especially true, when it comes to like really deep manholes. It's really hard to get a cleaning nozzle down into a very deep manhole when you have to make a right angle down at the bottom into the pipe itself. And so getting engineers to understand, O&M issues when they design, and then, but kind of the premise of our story today is, knowing what's in the system, what's the inventory out there, what are their attributes, knowing where they are, having them on a map, and there's really a physical connectivity as well as a logical connectivity that you really need to understand as you start managing your system. And then, of course, once you know what you have and where is it, you kind of want to know what condition is it in, because that's kind of one of the key things of managing your system is how good is it, how is it performing, how might it perform in the future. And again, really CMOM was in response to mitigating SSOs, so you really have to have a really good understanding of your system. And actually, I kind of want to, let's fire up another poll here. With respect to this condition assessment, but starting off with, do you have an active CCTV inspection program? Pretty simple question there. Do you have an active CCTV inspection program? So wait a couple more seconds here. Looks like we have a resounding yes. That's awesome. Okay, a couple more seconds. Yeah, so we have a 79% response on yes, they have a CCTV program, and that's pretty well to be expected here in this audience. So having an active CCTV program with all that inspection data, and then taking a look at that and assessing the condition, helps you definitely start planning and scheduling work based on that. Do I have, a fats, oil, and grease problem? Do I have a roots problem? Do I have sags? Do I have cracks in my pipe? Really helps you start planning, and that takes me into my, repairing, replacing, rehabilitating. Am I going to just do a point repair? Do I have to line the pipe, or just, replace the entire thing? That really, all that information, starts feeding my response program, if you will, within my asset management lifecycle. And really, I'm taking all of that data, and I need it in a really, timely fashion, right? I need to be able to respond quickly to some of these events, especially if I have a pending stoppage. So, managing that information that's timely and it's relevant helps you start to prioritize those CMOM activities. And one of the best things I think about the manual as well, the CMOM manual, is, it talks about the personnel, right? Because in getting the appropriate training, especially those of you that are using the CCTV, you may be familiar, in the U.S. with NASCO and PACP, getting those certifications, and so it really starts to have an emphasis on trained personnel, and really the underlying component to all of this, of course, is data. Data, and more data, that it takes to help basically manage all of this. So one of the things I think, that was interesting from my perspective, when I was at Colorado Springs Utilities, we were in a consent decree on our sanitary sewer. It was actually a voluntary. We entered into an agreement with the EPA, basically the Colorado local EPA, if you will, and some of the perspectives, from a budget perspective, it was really the worst and best thing that ever happened to our utility for the sanitary sewer program. Wastewater is not a moneymaker per se. It was a portion of our water bill, and it was actually a portion of, the winter flow, base flow. So it just wasn't funded very well. And this, the system, it was the first one buried, and therefore the first one forgotten. But the consent decree brought quite a bit of attention to the wastewater system, and of course we saw the funding start to pour in. Still not enough, but it was definitely much better from a budgetary standpoint. From the organization staff perspective, as I mentioned, with CCTV, and if you're getting PACP certifications, kind of helps elevate the staff, if you will. The consent decree was this rallying cry for all of our wastewater employees at the time. It definitely elevated the importance of the CCTV crews. They became a critical cog in the utility as kind of our first line of defense of collecting data. And of course, that PACP certification elevated their skill sets and started to bring, basically an awareness to the sanitary sewer professionals that we had. From the asset management perspective, like I said, I was the asset manager at Colorado Springs Utilities, and on the wastewater side, it was this consent decree and inspecting our sewer system. We started realizing, that assets could fail due to capacity. All along, I kind of thought it was, assets simply failed due to structural integrity issues, but no, they could fail to capacity. And nothing gets you more aware of that when you start doing your hydraulic modeling and you start to get D over D ratios of 1.0, right? I'll suggest that surcharging is not your friend in a consent decree because you're trying to mitigate SSOs, obviously, and every SSO counted against your decree. So you were definitely cognizant. You started doing real-time monitoring, but you also really wanted to model your entire system so you could understand again where surcharging might come into play. And when we did have a discharge, I quickly realized the vocabulary of differences between a release and a spill Only us engineers could define a release or discharge. Spill had a legal connotation, and only our environmental compliance officer could define a spill. So again, a consent decree definitely sharpens your awareness of all activities of your wastewater system. And with that, actually, let's go ahead and fire up our third poll here. I'll go ahead and bring this up. Is your hydraulic model tied to your asset management risk assessment? So if you could answer that question for me real quick. Is your hydraulic model tied to your asset management risk assessment? Give you a handful of seconds here to vote. We got about half of you out there voting so far. Looks like we have a resounding 62% say no, although 23% out there don't have a hydraulic model. So it's definitely something you might want to look into. It's very helpful to have such a thing in managing your system for CMOM. So, all right, and next topic, really technology. One of the things that we learned back then was, that CCTV really pushed our limits of technology. We were still doing VHS tapes with the video, but when we kind of started having to respond and wanting to do more things with IT, we converted those VHS tapes to MPEG files, and then of course all the new CCTV data collection was with MPEGs. And what we kind of realized, it was going to take terabytes of data storage. I mean, we basically calculated that the CCTV program was going to collect more data in 3 years than the entire history of Colorado Springs utilities put together in all of the utilities. So, unprecedented amounts of data collection. We, of course, us being engineers, not IT people, when we started having to learn new technologies like storage area networks at the data center, we thought, well, we'll just go to Best Buy and get a $300 hard drive, and we quickly learned that no, you can't quite do that. There's enterprise IT that comes into play, and so we learned lots of things about technology. And then again, data, and more data. Back then, trying to manage all that data was just a daunting task. We started building a lot of custom code, a lot of custom systems to kind of tie all that together, and it was quite complex. And yet, today, it's in a COTS solution, and that's really what Tony is going to talk about. So with that, I'm going to turn this over to Tony. He's got a kind of an introductory slide here to talk about what he's going to show. Tony?
Yeah, thank you, David. Hello everybody. As you can tell, I'm based in the UK. Worked for Innovice for 10 years prior to joining Bentley Systems. So I'm a returnee and was previously product manager for Infonet. So thank you for attending this webinar. I'm starting off with a slide before I get into the demo. The reason for that is I just want to explain some of the component parts of our solution for asset management. And this slide shows it very well indeed. And also to show the link to ICM, InfoWorks ICM. When we think in terms of CMOM, obviously CM in CMOM stands for capacity management. So that could be a conveyance issue related to service defects like fat, oil and grease and so on blocking the pipe, but it also could be a capex problem in terms of not having big enough pipes or having gradients and slopes that can convey the flow. And the OM part of CMOM, of course, is operations and maintenance, which is more aligned to asset management processes, traditional asset management processes, rather than necessarily design. So we're trying to cover those two aspects really in this presentation and demonstration. So I'll talk about a solution offering, although you don't need all of these component parts to be able to do a CMOM program. Let's start off with the hydraulic model, InfoWorks ICM. Obviously, that's the Innovice hydraulic model, which is tightly integrated with Infonet, and you'll see some of that towards the end of the demonstration. Infonet is the asset management system, the data management hub, if you like. This is the place where all of your asset information, your inspections, your surveys, the incidents, CSOs, SSOs, odor complaints, and so on, and your intervention records. Those are the work orders, your pipe cleaning programs and pipe repair programs. They'll all reside in the Infonet environment in the desktop asset hub, as it's labeled here. Now, we hope that from a CMOM perspective, a lot of the work that you'll do in order to mitigate against CSOs and SSOs will be to go out and investigate your network. You'll be performing SSES type studies to go and locate areas of RNI. Much cheaper to fix RNI than to, at source, look for those cross connections, look for those properties that have connected their storm drains into the sanitary sewer, right? It's much cheaper to do it at source rather than throw a lot of capex and build big tanks and upsize the treatment plant and so on, right? So that's what this demonstration is going to focus on. Now, we hope that if you were to go and do your field work and all these lovely inspections, that you might consider using Infonet Mobile, which is obviously, again, it's totally integrated with Infonet so that scheduled tasks can be then dispatched by Infonet Mobile to the field, and then field crews to complete those work orders and tasks, and then push those completed work orders back to Infonet, a sort of office to field, back to office type of approach. Infonet Web is our new web-based Infonet system for view only to democratize all of the data that you'll see that's present in Infonet. That's going to be released in May. And then, of course, we've got InfoMaster, which serves a particular purpose related to to capital investment planning. This is to prioritize assets and to look at costing, to determine rehab strategies and that type of thing. And that system, InfoMaster, will be fed by the Infonet data hub, CCTV inspections, pipe failure, bursts, and that type of thing. Right. So if you can switch me over to my desktop, David.
Okay, it should be on its way.
And can you just confirm that you're seeing?
I see you very clearly.
That's great. Thank you. Okay. Right. So this is Infonet. Infonet basically has a master database underpinning the software. There are three types. There's a proprietary database which has been developed over the past 20 years by Innovice, and we consider that the most optimal and optimized database, for the type of work that you do, and certainly for asset management purposes. But we also have an Oracle version and a SQL Server version of the database. But of course, there's added costs to the end user because you'll have to have an Oracle license and maybe an Oracle DBA specialist. So we typically would recommend the proprietary database, completely optimized to the type of work that you do. Now, you can see I've got a master database open on the left-hand side in the Infonet Explorer. You can see there are various elements in this master database. We have asset groups, selection list, SQLs, queries, themes, layer lists, and so on. Just consider those folders for the moment. And it's in these folders where we save the particular workflows in order to reproduce over and over again, right? And also to provide, if you create, for example, a theme, that becomes available to other users of the Infonet system. So the Infonet database is a multi-user. You can do short transactions and long transactions. It handles commit conflicts, where somebody says it's an 8-inch and somebody says it's a 10-inch. So it has all of that built in, ready to go. Okay, very simple to understand. If I then move into the actual objects themselves that we're showing in the map. So quite often what people say to me is when I demonstrate this is, oh, this is a GIS. Well, it has GIS capabilities, it has mapping and geospatial capabilities, it also has network modeling capabilities such as tracing tools and connectivity tools, that type of thing. So it's probably more than a traditional GIS. It's more of an engineering GIS, specifically targeted and aimed at delivering the optimal capabilities, for the type of work that you do in and around network modeling and network management, right? So if I very quickly run the network summary tool, this is going to query the entire network for this network, and it's going to produce a report. So we can quickly see now from this report, the sort of metrics, the statistics of this network. So we're looking at the number of pipes, 37,756. There are other types of links in this network, which increases the number actually to nearly 80,000 links. You can see that's 7.6 million feet of pipe. You can see the number of nodes. It's up to 79,181, and all the different types of nodes that are listed. So you're starting to build a picture of what the database actually contains in terms of its data model. It's probably the most comprehensive data model that you'll ever come across, and all of this is provided out of the box, straight off the shelf, as it were. If we move down to other assets, you can see we have other assets related to pump stations and valves. Then we move into the survey area. So this is showing the number of CCTV surveys allocated to pipes. So there's currently this network in this database is managing 23,659 surveys. So 33% of the pipe, approximately. 33,521 manholes. And again, you can read off these numbers, so I don't need to repeat them. But again, I'll just point you to the fact that we're actually managing, all of these different types of inspections that you'll carry out as part of an SSES type of study, right? Smoke tests and drain tests and FOG and so on, and new stuff like the new acoustic survey that's becoming more and more prevalent. Then we look into the area of repairs, and you can see that we've got nearly 9,000 pipe repairs, and we've got over 17,000 manhole repairs in this database for this network. And other types of repairs, though, over 32,000, 27,600 pipe cleans, and so on. So again, I hope you're picking up the idea that we're not just talking, when we talk about a data model and a schema, we're just dealing with the asset register, right? The traditional physical infrastructure, something you could hit a hammer with, right? What we're talking about here is all of the event-based operations and maintenance type of data that we're collecting and maintaining. And again, we're down into the incidents area. So you can see the number of incidents that have been reported, 23,238. And the different types of incidents. Obviously, flooding incident is one of the crucial ones that we're dealing with here, with sanitary overflows. And then various other bits and bobs. But so this gives us some sort of an idea of the size of network that we're dealing with. About 80,000 pipes, 80,000 manholes, and an awful lot of CCTV data and inspections and interventions and incidents. Okay, so let's move on. Right, so what I'm going to do now is reinforce that message about the data model and the data schema by opening up a different view of the data. So obviously this is the geospatial mapping view of the network. I'm going to open up the grid view now for assets. Right, and if I just expand the bottom of the screen, you begin to see, as I drag it across, the different types of assets that we're able to manage. Again, this data model, this schema is completely out of the box. It's ready to go, but you can add to it, and you can configure in various different ways to suit your needs. So, you start off with this, and then you'll configure and modify as you see fit. So we've got nodes. So what we do is we have a node object, and then we have subtypes of nodes, so manhole, cleanouts, and so on. Then we have pipes. Again, we can have different types of pipes, pump station, pumps, weirs, and so on. You can see all the way across the screen the different types of assets that we manage. Now, your eyes aren't deceiving you. There are a lot of colors in this spreadsheet grid view, right? And that's because these values are actually assigned a flag, a data flag, and this is critically important when we start looking at auditability and transparency of data and information, particularly when you're reporting to your regulator. And that'll become a little bit clearer, when we go through the demo a bit longer. Right, so let's close the asset grid down, and now we'll open up the inspections or the surveys grid, right? And again, if I just expand the bottom of the screen, we can see we've got manhole surveys, CCTV surveys, GPS monitoring surveys, flow monitoring surveys, dye tests, smoke observation, defect observations, drain tests, and so on and so on. FOG inspections for permitting, and acoustic survey, which is the latest one that we've added. So again, a very comprehensive set and list of inspection types for doing SSES type of work. So let's close that tab down, and this time I'll open up the incident window, the incident grid, excuse me, the incident grid. So these are the customer complaints, the blockage incidents, collapses on pipes, pollution incidents, flooding incidents. Obviously, that's of interest to us because of the SSO and CSO issue, and odor incidents. So again, very comprehensive. Out of the box, ready to go, but you can configure and change. And you can see that, again, in this view, lots of color going on, which relates to the different flags, right? The DAF in this case, we've got a DA, and this green one here is a JO. Now, these flags can be assigned according to imported data. So you could have a flag for GIS, for example. You could have a flag for from the field. You could have personal flags related to your own persona, so that when you make a change and edit, your flag gets assigned to that value that's changed, and that can be audited by yourselves or by the regulator. Okay, so that's the inspection, the incidents, and finally let's move on to the repair. Right, here we go. Here's a repair. So we've got pipe repairs, and we've got manhole repairs, pipe cleans, general maintenance, and so on. Okay, and again, the color coding related to those flags. So just to reinforce the flags, if I just come up here, you can see we've got a whole list of flags here related to particular people, importing from another system, from data stream. There'll be one for GIS import here, and GPS survey. So this is where we assign the flags, and they get carried through the database. Okay, good. So so explain the data model very quickly, and the data schema related to that. What I'd like to reinforce, though, is this concept of Infonet being asset-centric. And I like to describe this in terms of what I call the 5 I's of asset management. So the first I is the infrastructure, the physical infrastructure. That's your manholes and your pipes. So now, if I have that physical infrastructure and that asset register geometrically, I can then locate those assets. I know what they are, and I know where they're located. The second question then related to asset management is what condition is the asset in, and what is the remaining life? And you know that by doing inspections. So those are the CCTV, your condition-based inspections, your GPS, your manhole surveys. So now I know what I own, I know where it's located, and I'm getting an understanding of what condition my assets are in. The third question then is, how is the network performing? How are assets performing? Are they delivering service? And you know that through performance issues and problems on your network. And that's related to the incidents, right? So all of your SSOs and your CSOs and your odor complaints and your blockages and collapses, okay? Now I know what I own, I know where it is, I'm understanding the condition of the asset and the remaining life. I'm beginning to understand the performance from my incidents. The next question is, what are you going to do about it? And that references interventions. So these are all the different types of repairs, whether it's CapEx or OpEx, pipe repairs or cleaning programs, whether you cure in place, you slip line, or you need to remove roots, so you go for Duke's method, or you rod it, or whatever, right? Those are the interventions. Now, in Infonet, what we try to do is we try to ensure that all of those event-based operations and maintenance aspects, they're all time-stamped, they're all, a reason for doing it. All of those actually hang off the pipe, if you like. They reference the actual asset itself. So all I've done here is opened up one of these folders I told you about earlier, where I have this selection of an interesting pipe. Not a very imaginative name, but if I zoom to that selection, now you can see I've selected this pipe by just dragging out that pre-selected selection. Okay, so if I now select this pipe, in order to demonstrate this idea of asset-centric asset management, I'm clicking on the pipe. I can now open all associated events in a grid view, like we had before, right? So along the bottom here, you can see we have 2 nodes collected either side of the pipe, thankfully, for connectivity. here's the pipe record, but now we can see we have 13 CCTV inspections. So one row is one CCTV inspection. Okay, I hope you're following this. We have monitoring surveys. This is where we placed a flow monitor, and we're collecting the time series data and storing that in the time series database that Infonet comes with. So we have 5 locations in this network. Smoke tests. There are 2 smoke tests associated to this pipe. We have pipe repairs, 2 of those. We have 12 pipe cleaning programs over time. And then we have properties. These are actually the customers that are associated to that sanitary pipe. So the flow from these customers goes into that sanitary pipe. So you're getting to see what I like to term the biography of an asset, showing a timeline from when the pipe was put in the ground, and every time we touch it, there's a date, there's a reason, there's a resource, and there's a cost associated with that. And we want to preserve that information as a sort of biographical view of the asset, and that's possible through recording everything that's ever done to the pipe, in this case, over time. And another way of viewing this is to what we call the browse related. And over on the right-hand side now, you're seeing the object browser window open. And so for this pipe, we can see all the customers that are associated to that pipe, and those are these. If I just select, those are these. These polygons, right? These polygons associated to this pipe, right? We can see the number of CCTV inspections again. We can see the number of smoke tests, pipe repairs, and so on. Okay. So the biographical view of the pipe, all of the events that have happened over time. And in this view, I can simply click on any of these historic CCTVs and pull up the CCTV data for that, for that inspection against that pipe. So this is what I like to call asset-centric, with all of the events associated with it, and it provides a biographical view of that asset over time. Through these event baits, these things that have happened to it over time. Okay, right. So what I'd like to do now is just to explain how we actually populate this amazing database schema that we have, how we start to bring in data. I'm not going to do an import in this case because that's really boring. I just want to demonstrate and show some of the tools that are available for doing that. So we have a number of tools to do this, right? We have what we call the Open Data Import Center, right? And this is where we specify what type of data, what type of Infonet network object, or indeed repair or incident that we're going to be importing. So we specify that. Then we use this drop down to be able to specify what the source type of the data is. You can see a list of XML, geodatabase from ESRI, and so on, CSV, and so on, right? And then we specify the file, and then in the below grid, this is where we map the Infonet object to the import field object. We can save that configuration for future use. Most important thing, we want to set a flag for that. So we say it's coming from, if it's from ArcGIS, we may have an ArcGIS flag or a GIS flag, and then we hit the import, and that would import the data. So that's one way of importing. We also provide sort of generic importers for inspection data. So if I go back to the import tool and we go to the import CCTV survey data, for example, here we have the import PACP, LACP, and we support all versions of PACP and LACP up to version 7. I think that's the most recent, right? And that's the one that's most relevant to North America, clearly. But we of course support other standards across the world, Australia standards and German and European and UK standards. And again, for the manhole survey, which is typically what you'll be doing, right, as part of a SSES type of study, we can support the MACP manhole survey import, typically from an Access database. And again, there's a whole bunch of other importer tools, right, that we can use. Okay, we can also export from Infonet if we want to be good data citizens with other systems. And again, like we had an import center, we've got an output, open data output, export center, same type of thing, but from the reverse, taking data out of Infonet and pushing it to ArcGIS, geodatabase, feature classes, or whatever. We provide that tool. And again, there are other types of exports that we might support. right? Like for SWIM, for example, and to other survey data. Very comprehensive set of import and export tools for the type of work that you do as a CMOM project and part of an SSCS type of excuse me, of study. Right, what I'm going to do now is switch over to another network and demonstrate that process very, very quickly. And what's useful about this is what I'm going to do is actually build a network from a manhole survey and a GPS survey, which is typically what I guess, as part of a capacity management program, and certainly, for a model building, hydraulic model building process, you'll send crews out to do manhole surveys and GPS. Now, my argument is from a hydraulic modeling standpoint, you should be building the hydraulic model from the asset register. You shouldn't really jump straight into the hydraulic model because the data requirements are different, right? What you should be doing is actually collecting data as part of an SSCS program and providing that as part of the asset management system in order to move the knowledge forward, right, and the data and information forward, so that at some point into the future, the hydraulic modeler will then update the hydraulic model from the asset register, because that data is live. And more importantly, you can audit that data in the hydraulic model because of all the auditing tools that we have available in InfoNet. So build your asset register first, build your asset management system, go out and collect your data as part of an SSCS program, contributing to your asset management program, and then build the hydraulic model from the asset register, right? And I'm going to show you that right at the very end. So let's do a very quick demonstration of this using those important flags that I told you about. So I'm going to import my manhole surveys actually from a snapshot file that I created. This is a particular type of exchange format that InfoNet supports that we've developed. And what I'm going to do now is, as you can see, those manhole surveys have appeared located. And if I open one of those manhole surveys, can you see all these flags that I spoke about before? This is an MACP, so we've got the incoming pipes and the outgoing pipes, cover details and so on, right? I'm not showing any data here, but you get my drift. So we've imported the manhole surveys, and what I'm going to do is commit those manhole surveys to the database. So manhole surveys imported, snapshot file, right? So please bear with me while I type this out. It's quite important that I do that at this stage. So now I've committed and I've created a new version of the network, which only contains manhole surveys. Okay, my next process is to actually create create assets from that manhole survey. Bearing in mind this is just a manhole survey; they're not assets at this point of time, right? So we provide tools in order to be able to start building the assets from the manhole survey. So I'm going to update the network, create assets from the manhole survey. So this is the manholes and the pipes. So I'll run that, and here we go. It says it's created 23 nodes and 26 pipes. Okay, and I'm going to commit. As you can see, it's starting now to build the network for me. It's joining up the dots. Okay, so I'm going to commit again to the database. And I'm going to say updated from manhole survey, if I could spell right. And I'm just going to copy the notification that I got. Now I've created a second version of the network. The first version had the manhole surveys. The second version has the manholes and the pipes. And I'm going to use a particular tool that we have here to join up these pipes that are hanging, right? Clearly, this is the same pipe because they're pointing at each other. So I'm just going to do that very quickly using the inference tool. Right, and now they're joined up. I hope you can see that. They're joined up. And again, I'm going to be a good data citizen, and I'm going to commit to the database so that everybody else in the organization can see my changes. And I'm going to say joined pipes. Okay, simple as that. Right, now I've committed. Now, I'm looking at this manhole here, and I'm thinking that's in the wrong location. So I've tasked my field crew using InfoNet Mobile, hopefully, but it could be ArcGIS Collector or whatever you use, to go out and do a GPS survey. And I'm going to import that GPS survey using the Open Data Import Center that I showed you before very quickly. So I'm going to switch to a GPS survey. And I'm going to choose the GPS from a CSV file. I'm going to automap the fields. So this is the CSV fields, and this is my InfoNet object. And I'm going to be really good, and I'm going to change the flag to GPS. Okay, and import. So I'm only importing one object, in this case. And you can see the GPS survey is here. So let's just open that. And you can see the details. Here's the coordinates that we're interested in, that it's a manhole, it's this asset, and here are the GPS flags and the survey date. And again, I'm going to commit to the database. So GPS imported. Right, that's good. I've committed to the database. And now I'm going to update the location of this manhole based upon this GPS location. So network update from GPS survey. Okay, and it's updated the GPS. And we're going to commit to the database. And as you can see now, the manhole has moved to this new location, but it's left behind the manhole survey, right? That was originally collected back in the 21st of March. So it's moved the manhole to the new location and the pipe. If I commit to the database, right, now we've created another version. So the importance of this is that when I now select this manhole and open the manhole, okay, you can see that the X and Y coordinate for this manhole is now GPS, right? It's inherited the flag from the GPS survey. Okay, I hope you can see that. But crucially, if we look at the commit history for this node, we can see that this node actually changed only twice. The first time when we did an update from manhole survey, and the second time when we did an update from GPS. So we moved the location. So now in the commit history, the versions, so version 2 and version 5, if I look at the differences, we can now see what the differences were. In version 2, it was at this location, and in version 5, it's moved to this location. So HYS, when they did the manhole survey, whoever that was, got the incorrect X and Y coordinate. It's now moved to this location. And it's this type of auditability, right? You know, that ultimately provides transparency, you know, when you're reporting you know, things that you've done to the network over time, whether it's in this case a manhole survey or GPS. That's really crucial to provide that transparency. So we can show what a user did, why they did it, when they did it, what the consequences of that change was, and that's for a single independent asset, in this case the node. All right, okay, but we can also do it for the entire network. So if I open up the manhole surveys and GPS example, and I show commit history, we can see the 5 versions for the entire network, not just for this single pipe, but for the entire network. And then I can compare between version 2 and version 5, for example, and show differences. And this gives me a summary, a report on what changed from the nodes. So you can see the GPS coming in and the pipes. Okay, very useful tool to be able to demonstrate and audit and show provenance of data, you know, as you sort of begin to collect this inspection data. Now, the clever thing about this actually is that although this manhole survey has been left behind, geographically it's no longer associated to this manhole. It's in a different location. But if I open up the node, I can see associated objects, and it's the manhole. There's the manhole and there's the GPS. So I can now toggle to that manhole survey and open up the manhole survey form. All right, so that's what I mean by asset-centric, and why as you collect inspection data over time, you know, that has an event stamp, you know, a date stamp. You can then update your network based upon the latest inspection, and you can then justify to a regulator or to a board member, for example, or to a colleague, you know, why that manhole has changed. This is a very simple example, right? But it gives you the idea of how we use those flags and how those versions of the network are important. Great. So I'm just going to switch back now to excuse me, to the large network. Excuse me, I'm just got a cough. Right, so this is back to the large network. Now, as I said before, I often get asked, how is this any different to a GIS? And you know, it's not a GIS, but it has geospatial capabilities, right? A mapping. It's got a mapping canvas. We can connect to an ArcGIS geodatabase as background layers. We provide a mapping canvas for you that's free of charge. But it's actually more than a GIS. It's an engineering GIS. It's designed, it's optimized for the type of work that you do, for your line of work. So it has very powerful network modeling capabilities, tracing tools, connectivity tools, long section profiles, all those sort of things, right? And its performance, it's really fast in delivering, objects to the map, as you can see as I'm zooming in. So it has all those sort of geospatial functionalities you'd expect. So as you zoom in, more objects start to appear, right? Like manholes are starting to appear. But more importantly, to demonstrate the performance of InfoNet, I'm just going to run some tracing tools. So we provide out of the box all of these lovely tracing tools, and one of which I want to show you is connectivity. And what this does, it runs an algorithm that goes and finds all of those subnetworks, all those networks that are disconnected, in this morass of pipes that we're seeing on the screen, right? And now it gives us a published list of those subnetworks, and that was really fast. I mean, that's like 80,000 pipes and nodes. And then by clicking on the first record, we can see the largest network, the largest subnetwork highlighted. I click on the second one. Now this is useful, obviously, to start building connectivity. I mean, if I come down to one of these, say number 9, and finding and selected network, clearly this subnetwork that's highlighted in red should be connected at this point. So as we zoom in, we can see that is actually a separate subnetwork. Okay, so maybe that's quite valid, but it may be that this needed connecting. Now, of course, the advantage of this is that you can very quickly build that connectivity and provide provenance and auditability on that connectivity, right? So that when you hand over the data, as it were, to a hydraulic modeler, they don't have to worry about connectivity because it's built in from the asset register. Now, in this case, if this was a disconnected network and it should be connected, you might then schedule a field crew to go out and do a manhole survey or some sort of survey in that area to try and discover a manhole that might be missing in the network. So as you can see, the idea that this is a GIS, yes, it is, but I call it a geospatial mapping. It has powerful GIS-like tools, but configured and optimized, for network management, right? It hasn't got grid-based modeling techniques and, location services and all those things that are GIS, projection, transformations, and so on. You'd rely on your GIS for that. And of course, you'd manage your GIS layers, your soil maps, or your land-based data and that type of thing, of course, in the GIS. That's not InfoNet's domain. Now, if I just zoom out to the network again, I just wanted to show you why, again, another example of why I think this is so fit for purpose for this type of network management. I'm going to choose the downstream trace tool, and hopefully if I click on the right pipe, you can see that it's now performed a downstream trace. That was so fast. And then we zoom to the selection. Okay, and it's from the top of the network, tracing all the way downstream, shortest path to the treatment plant. Okay, and using this selection now, I can then open up a long section profile very quickly, which is pulling in all those pipes and manholes and elevations. Now, this obviously doesn't make much sense at the moment because it's so condensed, but I can start zooming into the network, into the long section, and I can start moving around and up and down, right, as it goes from left to right, from high to low. And what you're also seeing are defects along the pipe from the latest CCTV inspection. And I can very quickly switch on the defect labels, and I can show structural scores based around those defects. So if I zoom into this area a bit more, we can start seeing and revealing the different codes, right? And the structural scores, like in a histogram, as we move down the pipe. Okay, so lots of different ways of viewing the data, in this case in a long section profile. Great. I'm just going to close that tab and check on my timing. 24 minutes. Okay, good. So there are some examples really of why I feel that this is highly configured, more so than any GIS on the market, traditional sense of the word GIS on the market. Now I'm just going to switch back to my my small network and zoom to the network extent. Over on the left-hand side, we have these folders I spoke about, and one of them is this folder called themes, right? Okay, and this is where I've stored different ways of viewing the data in terms of the symbology, the color of it, the line thickness, the labels that we provide. And what you do is you create those themes in Infonet using this tool. It's not a training course, so I'm not going to show you how to do that, but essentially all of these objects, you know, like CCTV survey and assets and inspection and interventions and incidents like pollution incidents, we can control the symbology of all those things in this view and hit the save button and save it to the folder of themes. Now so that means we can reuse those themes over and over again. And indeed, if other people are using Infonet in the same way, they can use the themes that I've created. So in this case, I'm only going to show the assets, right? What I want to show now are the incidents. Right, so now we're seeing incidents. So I've pulled out, and you can see my CSOs showing as these concentric circles. So we can start to see clusters of CSOs, right? From just a simple theme that I've created that I can make available to everybody. And you can see the blockage incidents and the customer complaints in different types of symbols, right? You can see those. And the same goes with work tasks. Let's open up the work tasks theme. And again, we're showing work tasks in this case. We've got pipe cleaning programs, this brown line here, for example. And of course, there is a way of showing the theme in a legend view, but you can start seeing, you know, different types of work tasks. The blue line is a pipe cleaning program. Now, maybe I don't want to show the pipe repairs. I just want to show inspections. So I drag the inspections out, and here we are, where we have all the different types of inspections. Okay, and if I zoom into this area here, we can see CCTV. In this case, this CCTV from this manhole to this manhole. Quite usefully, this is a partial inspection, so there's a gap where, you know, they came across some blockages and couldn't go through it. So that's very useful, just to show the fact that it's a partial inspection. We can show smoke tests in this view, of course. So if I just zoom out a little bit and go locate some smoke tests. Right, there's a smoke test up here, right, and so on. So very quickly, you can save these themes. You can save labels. I'm showing some labels here, but again, the labels are very powerful in Infonet. In fact, I showed this tool to a consultant in the US a couple of weeks ago, and I think I was being very clever showing all this excellent data management stuff. And when I started moving these labels around and configuring them, you know, that's what they were interested in. So I was amazed, you know, I was showing all this great data management stuff and work that, you know, for a SSES type of study, but the labels were really what turned them on, which was quite funny to see. But then I really started to hit home when I showed them tooltips. So we can hover over these objects, right, and show them in tooltips and expand the view and show the flag. So the color coded relates to the flag for the smoke test. If I was to choose the tooltips with photos, so I'm dragging out the tooltips for photos, as I hover over, now what it's doing, it's reading all of the different types of documents that we can store against an Infonet asset or survey. And in this case, we have a you know, a location sketch, but we have photographs as well that we can show interactively, right? And again, all of those types of ways of viewing the data can be stored over here on the left-hand side in these folders and be reused over and over again. Right, so I'm starting to get close to my time, so I want to move swiftly on to CCTV inspections and spend a little bit of time there. So what I'm going to do is just zoom right out of the network. And I'm going to throw inspections only on, and there is a particular inspection that I'm interested in showing you. So if I just open that selection, this CCTV inspection, and zoom to the selection, it's this pipe inspection that we saw earlier. So what I'm going to do is open up that CCTV inspection. Okay, here's the PACP standard, how we present it with these tabs, you know, showing the details, showing the defects, the individual defects along the pipe, you know, the distance along the pipe, you know, the video number, the video time, and so on, right? Now, in this case, we actually have a video associated with this CCTV inspection. So, like most inspection programs, you can click on that on each defect, and it jumps to the relevant location on the video. And of course, you can play the video, right? And you can obviously come into here and you can add your own defects if you see fit, right? Okay. Now Infonet, what we do with Infonet is we import the data using the PACP import standards, and then we calculate the scores, right? We actually embed the algorithm in Infonet to be able to do that. So if your survey contractor isn't providing the actual ratings and the indexes, Infonet can do that for you. We'll calculate it for you. But additionally, what it does, it takes the PACP ratings and then updates the pipe record, right, based upon that CCTV inspection. So again, if we go to the condition tab, we can see the different grades. These are the structural and service condition grade, but we can always go back to the original CCTV data, right? So this is what I term the asset-centric way of viewing all of this data. It's all self-contained against that pipe record. Right, so if one quick thing I wanted to show was the profile view. So again, if I pull up the profile view for this inspection, and then I go and switch on as I showed before, we can look at service defects in this case. Yep, you're starting to get a really nice view of the distribution of defects along the pipe, the depth, the green line, the top green line is the depth. If we had a terrain model, we'd show the undulations of the terrain model, so you can calculate the depth to these, defects on the CCTV. So I'll very quickly run through the CCTV data management and the way that then we import from PACP I showed you before, and how we update, like we did with the manhole surveys, we can update the CCTV surveys using the algorithm, and then update the pipe condition from the CCTV, retaining the historic data. Right, so the last thing I'd like to do is two things before we close. I'm just seeing what time I have. It's 32 minutes I've been in. I've got another 5 minutes, I believe. I'm just going to run some example reports. So Infonet comes pre-packaged with all of these types of reports, right? There are 49 of these built-in reports for you. You can actually configure these reports if you can do work with HTML. Not recommended, but these are standard reports that we provide. We also provide custom reporting through Excel templates, but we also provide a dashboard view. So if I just zoom to the network, and I have a dashboard example which I'm just going to open. Here we go. Here's a dashboard showing for this network the number of flooding events over time, the number of CCTV surveys for this sewer catchment, flooding events by year, the amount of CCTV we surveyed in terms of survey feet, the different types of flooding, percentages of causes, right? Debris, broken, collapsed pipes, and the number of surveys that have PACP ratings in these ranges. So you can configure these dashboards, for reporting purposes. And one last thing I'd like to do is show how we can then integrate with GIS layers. And I've got a railway line that's cutting across the network here. And what I'm going to do is run an analysis to discover all those pipes that are grade 4 or 5 in terms of its condition that are underneath a railway line, right? So there's a GIS layer for railway, and we're going to query that railway line and see all those pipes that cross those railway lines. So if I run the query and I zoom to selection, we can see that this pipe has been selected, right? And it may be that this pipe then becomes a high-risk pipe, high consequence of failure if it collapses. So we might want to either go and repair it or put an intervention program against it or inspect it over time. Right, so that's all I wanted to show in terms of the data management capabilities of Infonet. So what I'm in now is if you can see InfoWorks ICM and Infonet Desktop, I'm in the same application, but I'm viewing both the InfoWorks network and the Infonet network. If I just tile these vertically, so you can see that we have now the Infonet data and we have the InfoWorks model. So if I drag out the Infonet network, and zoom to background network. Right, here we go. Here's the background network in Infonet. I'm just going to run a quick trace tool, upstream trace from this point here. Right, that wasn't a very good one. Let's try another one. Right, here we go. So in Infonet, I'm going to do an upstream trace. Excuse me, I do apologize. right, there's my upstream trace in InfoNet, and it's selected those objects in InfoWorks. That is the background layer, which is an InfoNet network. And all I'm going to do now is use the import tool. Excuse me. I'm just going to use the import tool to update from collection system. For the selection. And this is going to then extract the assets from InfoNet and create the network model in InfoWorks. Okay, so here we have an InfoWorks. So if I now, if I turn off the background theme, switch it off, you can now see that we've built the InfoWorks network from the asset register in InfoNet. And again, I can very quickly just pull the InfoNet network across so that the modeler now, when you're doing your hydraulic modeling, right, I'm in InfoWorks, this is a hydraulic model in InfoWorks, I can actually get access to all of that rich contextual data related to the network, showing all the different CSO events, you know, I&I studies and all that good stuff. But now I'm a hydraulic modeler working in InfoWorks ICM. Showing how simple and easy it is to integrate between the asset register and the model. So thank you very much for your attention. I do apologize, I've gone a little bit over, but I'll hand it back to David and for any questions that you might have. Thanks very much.
But we did get a handful of questions, and so if we don't get to them here in the next minute or two, definitely send Tony or I an email, and we can answer your questions directly. But we'll take a minute or two. We'll go over a handful of these. One of the questions I think was pretty well answered there. You know, if you really for Tony here, could InfoNet be used for your entire network, even if only a portion of your network is modeled in the ICM? I would say yes. That's, you know, the difference between the asset registry and the modeled registry, if you will. But Tony?
Yeah, absolutely, and it's actually being used by a number of our users in that way. They've created these catchment areas or sewer sheds where they're putting, you know, they're using InfoNet to determine where to put their flow monitors, right? And according to the national, you know, the international standards, your flow monitor should only be monitoring 4 miles upstream, right? 4 to 5 miles upstream. So they're creating these sewer areas and then actually modeling those individual sewer areas in InfoWorks. Obviously, you can combine them all in an all pipe model, but yes, you can actually you know, select that area of interest in InfoNet, that catchment, that sewer shed, you know, the modeled area, and then use that for you know, for creating the hydraulic model, and then using the flow data obviously for calibration purposes. So yeah, that's exactly what it's being used for.
Yeah, and I think the next question will take maybe a little bit more in depth, and we can answer it via email. But really, the question was surrounding, you know, if InfoNet doesn't do the hydraulic modeling, how can all those modeled networks, you know, be linked to, say, InfoWorks ICM, InfoMaster, the GIS, basically how all those updates are reflected?
Yeah, so obviously I tried to show, I covered an awful lot in that presentation, I do apologize, but I tried to show this idea of committing to the database, creating versions. So InfoNet is this system that you'll be using day in, day out. You know, it's like the grunt work of asset management, collecting data in the field, bringing it into InfoNet, creating a version, and that carries on day in, day out. And occasionally, obviously, then you want to leverage that data for building a hydraulic model, and that might only happen every month or every 3 months. And the same goes for InfoMaster. You're not going to be doing capital maintenance planning every single day of the week, right? Or maybe you are, but that'd be unusual. You might be doing it every couple of weeks and reviewing the previous capital maintenance programs, right? But you want to be able to get data in order to do that. And InfoNet is the place for that, right? Because it has this rich context of CCTV, pipe pipe bursts and failures and collapses and all that good stuff, which you'll use in your capital maintenance program using InfoMaster. So again, we have methods that we haven't shown here of connecting InfoNet data to InfoMaster using an application programming interface. And the same goes with other hydraulic models. Maybe InfoSwim, for example. I showed you there was a swim export routine that InfoNet has that can create the swim files. But we also have an API that could be used again, to push the data from InfoNet, into the third-party systems, and not just Innovyze systems, right? It could be anything that API supports. That's how it works. InfoNet is the day in, day out, the data repository for all this event-based data and making changes to the network, which then can be leveraged by these other applications. And I just showed InfoWorks ICM and how easy it is to create that hydraulic model from InfoNet because of that tight integration.
Yep. Well, I think there's actually a couple more questions. I think we can answer those via email, but also it seems like the nature of another webinar. Lots of interest about how we would move data in between InfoNet and InfoMaster, doing the risk modeling in InfoMaster and pushing it back to the asset registry in InfoNet and vice versa. So probably the nature of a webinar all in itself. Again, thank you for the questions. So we're frankly running out of time, and if you didn't get your question answered, send an email to Tony and I, or we'll make sure we explore that more in depth. So thank everyone for your time. Thank you, Tony, for giving us an amazing demonstration, and hope to hear from all of you soon. And I think with that, Caitlin, we're going to go ahead and wrap it up.
Yep, thanks very much, everybody.